What if I told you that Saturn's largest moon, Titan, a world over 1 billion kilometers away, is hiding something that could redefine our understanding of life itself? Imagine a place where rivers of liquid methane carve through canyons of water ice under a thick orange haze. For decades, scientists have dreamed of exploring this alien landscape, and now what they've found is more astonishing and, frankly, more terrifying than anyone ever predicted. Titan is an anomaly in our solar system. It's the only moon with a dense atmosphere even thicker than Earth's. This atmosphere is a rich cocktail of nitrogen and methane, which, under the faint light of the distant sun, creates a smog-like haze that shrouds the surface in perpetual twilight. The temperature hovers around a bone-chilling -179 degrees Celsius, cold enough for methane to exist as a liquid. This is the only other world we know of with a stable liquid cycle, complete with rain, rivers, lakes, and seas. But instead of water, it's liquid hydrocarbons. For years, this bizarre yet familiar landscape has made Titan a prime candidate in the search for extraterrestrial life. Not life as we know it, breathing oxygen and drinking water, but something far stranger. Life based on a completely different chemistry. Scientists have theorized that life could potentially emerge in these frigid methane seas, using acetylene as an energy source and breathing hydrogen instead of oxygen. It's a concept straight out of science fiction, but the chemical ingredients are all huygens To investigate this possibility, missions like the Cassini-Huygens probe gave us our first tantalizing glimpses. In 2005, the Huygens lander descended through Titan's atmosphere, capturing breathtaking images of a world that looked eerily like Earth. It landed on a damp plain, revealing a surface littered with ice pebbles, smoothed by liquid flows. Cassini, orbiting Saturn for over a decade, used radar to map vast methane lakes in the northern hemisphere, like Kraken Mare and Ligeia Mare, each larger than Earth's Great Lakes. Data from Cassini's instruments revealed a peculiar chemical imbalance. Models of Titan's atmosphere predicted that sunlight and Saturn's magnetic field should be producing vast quantities of acetylene, which would then rain down onto the surface. But when Cassini measured the atmospheric composition, the acetylene was largely missing. At the same time, another mystery emerged. Hydrogen, which should have been evenly distributed, was disappearing near the moon's surface. It was as if something on the ground was consuming both acetylene and hydrogen. This is exactly what astrobiologist Chris McKay proposed a hypothetical methane-based life form would do. It would breathe in hydrogen, react it with acetylene, and release methane as waste. The discovery that these very chemicals were vanishing at the surface sent a shockwave through the scientific community. It wasn't proof of life, but it was a tantalizing clue, a chemical fingerprint that demanded a closer look. This brings us to the future of Titan exploration and the concept of a mission like the Dragonfly rotorcraft. A nuclear-powered drone designed to fly through Titan's dense atmosphere. Imagine a car-sized quadcopter landing at multiple sites, drilling into the surface, and analyzing samples in its onboard laboratory. Its mission: to find the source of these chemical anomalies, and ultimately, to search for biosignatures, the telltale signs of life, past or present. Now let's go beyond the official mission plans. Let's speculate on what such a mission could truly uncover. As Dragonfly explores, it sends back data confirming the missing hydrogen and acetylene. It finds complex organic molecules in the soil, far more intricate than anything produced by simple chemistry. The evidence builds, pointing not just to the possibility of life, but to a thriving, active biosphere hidden within the frigid landscape. And this is where the story takes a terrifying turn. For life to exist on Titan, it would need to have solved incredible biological challenges. It would need cell membranes that don't freeze solid, but remain flexible in liquid methane. These hypothetical azotisms would be made of nitrogen compounds, fundamentally different from the lipid-based membranes of life on Earth. Its metabolism would operate at an incredibly slow pace, dictated by the extreme cold. Generations could span millennia. Now imagine our probe lands near one of the vast dune fields, the sand made of solid hydrocarbon grains. It drills into the icy bedrock beneath the dunes, and its instruments detect something unexpected. A faint, rhythmic vibration, a seismic pulse, too regular to be a natural moonquake. The probe reorients its sensors, trying to pinpoint the source. The signal is coming from deep below the surface, from within Titan's massive subsurface ocean of liquid water, which lies hidden beneath a thick crust of ice. This is the crucial revelation. The prevailing theory was that any life would be on the surface, in the methane lakes. But the real activity isn't on the surface at all. The surface life, if it exists, is just a byproduct, the faint echo of something much larger, much older, and far more complex, dwelling in the dark, liquid water ocean below. The chemical anomalies on the surface are not from simple microbes. They are waste products seeping up through cracks in the ice from a vast hidden ecosystem. What could be living in a dark ocean, miles beneath an ice shell, on a moon 1 billion kilometers from the sun? The energy source wouldn't be sunlight. It would have to be chemical, from hydrothermal vents on the seafloor, similar to the ones that support ecosystems in the deepest trenches of Earth's oceans. But here, the life has had billions of years to evolve in complete isolation. The terrifying part isn't that we might find microbes, it's that we might find something that has evolved far beyond that. In an environment with no predators and limitless time, what form would intelligence take? What kind of consciousness could arise in a being that experiences time on a geological scale? The seismic pulse isn't just noise. It's organized. It's complex. It almost sounds like a signal. We sent a probe to look for single-celled organisms in the cold, and instead, we may have accidentally knocked on the door of an ancient, sleeping intelligence that resides in the crushing darkness of a subterranean ocean. An intelligence that has been there, silent and waiting, for eons. The discovery on Titan isn't that there's life. It's that we may not be alone in our capacity for complex thought, and the first entity we meet could be so fundamentally alien that we are completely unprepared for the consequences. The universe is not just stranger than we imagine, it is stranger than we can imagine. What do you think is hiding in the depths of Titan? A simple microbe, or something more? Let me know your thoughts in the comments below. This kind of exploration is what pushes humanity forward, forcing us to question our place in the cosmos. If you enjoyed this journey to the edge of science, please hit that like button, subscribe for more deep dives into the universe's greatest mysteries, and check out our other video on the potential for life on Europa. Thanks for watching.